The moon is the most beautiful thing to behold in the night skies, the most accessible object you can spot anywhere on Earth. I call it Earth's closest companion. Besides bathing us with its glowing light on a full moon night, it controls tides, floods, and eclipses. What then is this strange mess that is lurking in our stellar companion? Will this huge glob destroy the moon? The moon, Earth's only natural satellite, orbits at an average distance of 238,900 miles. Believed to have been formed 4.51 billion years ago, not long after Earth, out of the debris from a giant impact between the planet and a hypothesized Mars-sized body called Theia, the moon is a differentiated body that initially was in hydrostatic equilibrium but has since departed from this condition. For decades, this was all scientists knew about this spectacular body until a huge glob showed up on its far side, followed by the discovery of ice water. In 2019, researchers discovered a large mass 5 times larger than the big island of Hawaii sitting on the far side of the moon, an unexpected occurrence. The structure is located at least 180 miles beneath the South Pole Aitken Basin, a massive crater carved into the lunar terrain billions of years ago when the moon's initially molten surface had cooled. The researchers proposed 2 explanations for the phenomenon. First, it could be remnants of dense oxides that formed during the final stages of cooling when the moon was covered in ancient magma oceans. But this suggestion wasn't feasible. Neither did the researchers have a mechanism to precisely explain the formation of such a layer specifically under the basin. According to Peter James of Baylor University, the blob is likely connected to the development of the crater and may represent the leftovers of an old impactor's metal core. While the extra mass isn't immediately visible from the surface, it appears to be having an impact, pushing down the lunar landscape in a strange ovoid depression that lies more than half a mile lower than the surrounding crater floor, known as the Central Depression. The unusual mass was identified by merging data from NASA's Gravity Recovery and Interior Laboratory, or GRAIL, mission with topography from the Lunar Reconnaissance Orbiter. This data helped the researchers in refining previous predictions for the thickness of the crater's crust and the density of the mantle, showing the unusual underground excess of material. Their findings give a hazy picture of what's going on both above and below ground. The more the mass, such as higher terrain or denser rocks, the greater the gravity. These maps distinguish between most of the moon's big craters and the South Pole Aitken Basin. Other huge craters feature mass cons, which stand for mass concentrations, discovered by scientists at NASA's Jet Propulsion Laboratory in 1968. But this one doesn't, hence even NASA doesn't understand how it formed or why it's there. In 2020, scientists discovered yet another mystery about the Earth satellite. NASA's Stratospheric Observatory for Infrared Astronomy, SOFIA, made an exciting discovery during a test that indicates the presence of water on the moon's surface. This discovery also shows that the water locations are not limited to the moon's cold, dark, and shadowy parts like the South Pole Aitken Basin, but it is distributed across the lunar surface. SOFIA's findings add to years of earlier studies into the presence of water on the moon. Several spacecraft, notably NASA's Cassini and Deep Impact Comet missions and the Indian Space Research Organization's Chandrayaan-1 mission, scanned the lunar surface and discovered signs of hydration in sunny locations. Those missions, however, could not determine whether it was in the form of H2O or OH. The water molecules come in H2O elements, same as the ones we drink, and was found in the Clavius crater of the moon's southern hemisphere. The Clavius crater is among the largest craters visible from Earth. From previous probes and observations, scientists have had no reason to suspect the presence of water molecules on the moon. According to the Nature Astronomy publication, the water molecules appear in a high concentration of about 100 to 412 parts per million, trapped in a cubic meter of soil across the moon's surface. That is almost equivalent to 12 ounces of bottled water. Paul Hertz, the director of the Astrophysics Division, was so excited about this discovery, he said, "We had indications that H2O might be present on the sunlit side of the moon. Now we know it is there. This discovery raises many questions about what we know about the moon and will change how we explore the moon in the future. Though the water discovery is minimal, about 100 times less than the amount of water in the Sahara Desert, it has led to questions about how the water came about and how the moon retained it in its harsh environment. Different speculations have attempted to explain the water creation on the lunar surface. Some say it could be due to micrometeorites raining down on the moon's surface. These meteorites could contain small amounts of water they deposit on the moon upon impact. The second hypothesis is the sun's solar wind. The sun's solar wind might have been delivering hydrogen to the moon's surface and causing a chemical reaction with some oxygen-carrying minerals to create hydroxyl molecules. The radiation from meteorite showers might be transforming the hydroxyl into water. These are assumptions and not proven facts about how the lunar water forms, but despite these speculations, the question of how the water remains on the airless lunar atmosphere surface is still a mystery. According to Hannibal in NASA, without a thick atmosphere, water on the sunlit lunar surface should be lost to space, but yet somehow we are seeing it. Something is generating the water, and something must be trapping it there. NASA believes the water retainment might be due to the water trapping into the cheese-like structure of the soil from high-heat micrometeorite impacts. Another theory is that the water could hide between the moon-grained soils and away from the sunlight. None of these theories has been confirmed, but when dealing with space, we can only speculate until we can confirm. Previous bids to discover water on the moon have always turned out negative until now. The earlier explorations of the moon reported the moon as utterly dry. Impact and orbital missions have only shown ice around the moon poles, but no water presence. Some of the comet missions have reported evidence of hydration in the sunny regions, but so far there has not been evidence to confirm if the water is of the H2O or OH elements until now. According to Casey Hannibal, we were curious to know how much, if any, was actually water molecules like we drink every day or something more like drain cleaner. The discovery of water on the moon came by chance. The SOFIA telescope was meant to look at distant, dim objects like galaxies, black holes, and star clusters. Due to the significant nature of the moon and its brightness, NASA decided to observe the moon harder. The moon test observation wasn't meant to reveal anything. Instead, an incredible discovery was made. NASA plans to hold more flights to the moon to explore and learn more about the lunar water presence. These flights will look for water and location, determine the lunar phases, and map out the water content for further testing. Nassim Rangwala said, "It is incredible that this discovery came out of what was a test, and now we know we can do this. We are planning more flights to do more observations." The data from the future tests will improve future moon missions, including NASA's Volatiles investigating polar exploration rovers. We might even have the first water maps of the moon. Exciting, right? Professor Frédéric Moynier, a cosmochemist at the Institut de Physique de Globe de Paris, posed a significant theory about how the moon got its water. He believes the moon and the Earth share the same water source, and that the water must have come about from a meteor impact that formed the moon. According to Professor Moynier, the moon rock has not changed much since its formation. He performed a test on some moon rocks from the Apollo mission. The rocks, like those in the South Pole Aitken Basin, contained some minerals and traces of water content. The water content found also exists in small frozen deposits and meteorite impacts on the moon. From this result, Professor Moynier formulated an idea of how water formed on the moon. He ran an isotope ratio on the water material from the Earth and that on the moon, and they had almost the same isotopes. This result suggests that water arrived on the moon at the same time as on the Earth, and the reason for lesser water on the moon might be due to the volatile nature of the moon. His theory supports the Mars-sized protoplanet theory that Theia crashed into the Earth in a shower of vapor and debris that cooled to form the moon. If this theory is correct, the moon got its water during the meteor impact before its formation, and a trace amount of oxygen and hydrogen suggests there was once more water on the moon than there is now. Professor Moynier's theory of where the water on the moon went led to his project, the Pristine. This project aims to measure volatile isotopic levels in lunar rock to determine where the water went. His experiments showed that the water must have disappeared due to evaporation. The volatile moon elements increased the evaporation rate of water from the lunar surface. He believes that the water vapor from the moon must have fallen back to the Earth due to gravity. Finding water on the moon signifies the chance for life to survive or grow, but NASA is yet to confirm whether the lunar water can be used as a resource. However, technology is advancing every day. It is only a matter of time till we determine what type of water is on the moon, if there is a way to generate more, and if mankind can make a living on the moon without much life support. We might have more conclusions with the next moon exploration in 2024. The discoveries on the moon's surface significantly impact future exploration attempts. The possibility of explorers carrying lesser water supply and more specialized materials is very appealing. It can also mean that the moon is habitable in the future and can grow life. However, this is all speculation, and there is, as of yet, no way to know where the moon's water came from. Future probes and missions will reveal a lot, and we cannot wait.